Okay, so now I'm recording. Okay, so okay, we start with thin lens. 7.3. Okay, today we start with thin lens. Okay, what is a thin lenses? Okay, it's a transparent material with two spherical refracting surfaces whose thickness is thin compared to the radii of curvature of the two refracting surface. So why is it called thin lenses? Yeah, is this lenses is considered thin because the thickness we compare with radius of curvature. Because you see, this thin lens is actually made of two spherical surface. So these spherical surface have their own radius. Yeah, maybe I should draw it out. Like for example, the biconvex lens. Okay, biconvex lens actually is made of two sphere. Yeah, it's made of two sphere. Remember that we learned about mirror last week. Mirror only have one spherical surface. See that? Uh, mirror. This is mirror. Uh, and this one is thin lens. Thin lens. So mirror only have one spherical surface. It only has one radius. Only has one radius. But thin lens, yeah, for thin lens, it has two spherical surface. Okay, just come in. It has two spherical surface. So okay, we put this as uh, surface 1. This is surface, yes, surface 1, surface 2. So the surface 1 is this radius, this surface 1, and surface 2 is this radius. Do you see that, class? Surface 1, this radius, the sphere is at the right hand side. The second surface, the sphere is at the left hand side. This is the radius 2. Okay, this is the radius 1. So why is it called thin lens? It's called thin lens because the thickness of the lens is thin if compared with the radius of these two reflecting surface. So the thickness of this lens considered thin lah compared to the radius. Like I see the thickness of this lens is considered very small compared to the radius. Actually, this I draw it too big already. The lens is not as big like that, like as thick as this. Yeah, the thin lens is very very thin only. Yeah, actually very 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 thin. Compared to the radius, is negligible lah. Yeah, the lens. This is R2, this is R1. So the thickness is very very thin compared to the radius. Okay, that's why it's called thin lens. Right? Okay, so we have two types of lens. We call it convex lens and concave lens. Okay, so what's the difference between convex lens and concave lens? If you look at these three, we have biconvex lens, we have plano convex lens, we have positive meniscus lens. Positive meniscus, or we call it meniscus convex lens. Yeah, convex meniscus. We call it convex meniscus. This one is concave lens. We have biconcave, we have plano concave, negative meniscus, or we call it concave meniscus. So what's the difference between these two? Here convex lens is called thick in the middle. That means you see, you compare this one, it's actually thick in the middle compared to the side. Yeah, the side is very sharp, isn't it? The side is very sharp, but the center is thick. The center is thick. So this one is called is thicker at the center. Thicker at the center. So this one is called convex lens. Yeah, this one is called concave lens because it's thinner at the middle. See, thinner at the middle compared to the side. The side is much thicker. It's thin in the middle. In the middle, but thicker at the side. This one is thin at the side, thick at the middle. Yeah, do you see the difference, class? Convex and concave? Huh? Do you see a difference? What I mean is convex lens means, yeah. So what is biconvex lens? Biconvex lens means it's thick in the middle lah, thick in the middle. Yeah. So the thickness here compare the thickness at the side. Yeah. So the thickness is thick in the middle. Thick in the middle. So this is a type of convex lens. Okay. But if you have a lens like this, you see that? You see this? You see this one? You compare the thickness, at the center, at the side. Which one is thicker? So at the side is thicker, isn't it? So it's thin in the middle. Yeah, thin in the middle. Okay, so this one is called concave lens. Okay, class, understand? Okay. Anyway, one thing I want to tell you is a convex lens is the type of converging. Yeah, converging light. Yeah, converging lens. It's a converging lens. Yeah, concave lens is a diverging lens. Diverging. Yeah, converging. What does it mean? That means all the light that comes, it will focus. It will focus at the focal point. Okay, it will focus. It can focus the light. Converging. If the one thick in the middle, it can focus the light. Yeah, converging, convex lens. But the one thin in the middle is called diverging lens. It cannot focus the light. It just diverges the light away. Yeah, it diverges the light away. Okay, this is about reflection. It diverges from the focal point. Yeah, the one thin in the middle. So there's the thick in the middle one. It can focus the light. The one thin in the middle, it diverges the light. So we not just biconvex lens. We also have other type. We have like the converging lens. We also have plano convex. We also have convex meniscus. As long as it is thick in the middle, okay. And the thin in the middle means we have plano concave, yeah, or concave meniscus, like this one. See that? This one is all these are concave diverging. Yeah, all these can diverge the light. Yeah, if these two also they focus the light. They are called, all these are called all these are called converging. Yeah, they focus the light. This one concave lens, they all diverge the light. Okay, why is it called like you see, why is it called biconvex? Why is this one called biconvex? Why is this called plano convex? Why is this called positive meniscus or convex meniscus? Yeah, because just look at the shape. Yeah, actually we can identify from the shape. Yeah, look at this one. You see, look at this one. Why is it called biconvex? Because if you divide into two, yeah, you look from the here is convex surface. You look from here, also convex surface, isn't it, class? It's also both also convex. So this is called biconvex lens. Understand? If you have another lens like this shape, if you have lens like this shape, so if you divide into two, what do you see from the left? I see a plane. I look from the right, I see a convex surface. I see a convex surface. So what is this called? It's called plano Plano, what? Plano, plane. Just combine these two lah. Plane, plano convex. Plano convex lens. Okay. This one both also convex, so it's called biconvex. Bi means double lah. Bi means double. This one plano convex means one plane is plane, another surface is convex. Okay, for your information class, for this plane, the radius is considered infinity. Yeah. So let's say this surface 1, this surface 2. For radius 1 is considered to be infinity because this surface is plane. It's considered like a very big sphere until it is plane. Until it is plane surface. So for plane surface, the radius is considered infinity. So we also here radius 2 is not infinity lah. Radius 2 is is a small sphere. But for plane sphere is considered radius infinity. Understand class? Then we also have this one like this. See this one anak bulan like that. Okay. This one is I want to ask you which one? Yeah. Is this one is called concave meniscus, or is it called convex meniscus? Which one, class? Which one? Tell me, class. This one is convex meniscus or concave meniscus? Come on, I need response. Yeah?
Convex.
Yeah, convex meniscus. Yeah? Convex meniscus because why is it called convex? Why is it called convex? Because it's thicker at the center. Okay? See this one? It's thicker at the center. So it's called, you can call positive meniscus or we call it convex meniscus. It can have either name, convex meniscus. This one is concave meniscus because it's thinner at the middle. Okay? So this one is convex meniscus. Is converging. Yeah. So it's not concave. Yeah, it's converging. It's converging lens. Yeah, converging. So what I can say is it's convex meniscus. Yeah, just look at the shape. This is thicker at the center. Okay, so all these converging lens, yeah, either is biconvex, plano convex, or convex meniscus. All these, their f value, all their because they are converging lens, so all their focal length are positive value because they focus alike. They can focus alike. Yeah, all these they can focus alike. Yeah, plano convex, they focus alike. Convex meniscus also focus alike. Okay, but for so they all are converging lens, convex lens. They are all convex lens. They all are F positive. But this one, the one thinner at the center or thicker at the side, these are all diverging lens. Yeah, they all have negative F value class. All of them have negative F value. They all diverge alike away. They all diverge alike away. Understand, class? They all diverge alike away. They don't focus alike. They all diverge from the focal point. No matter is biconcave, plano concave, concave meniscus, they all F negative. Yeah, diverging line. Okay. See that? We have biconcave because both sides are concave, plano concave, and this one also called concave meniscus. Concave meniscus. Okay, so after that, we have this, thin lens equation. Okay, we going, actually you look at this equation, 1 over f equal to 1 over u plus 1 over v. It's the same equation as we used before for mirror. Where is it? See? For mirror also use the same formula. 1 over f equal to 1 over u plus 1 over v. Same. But only the radius. No, only to find the focal length, r equal to 2f. This one cannot use for mirror. This one can only use for mirror. This one cannot use for lens. Cannot. Because why? Because mirror only have one radius. Yeah. But for lens, it has two radius. It has two radius. That's why just now you see you have a radius 1 and radius 2, isn't it, class? You have radius 1 and radius 2. Compared to mirror, mirror only have one radius. So C. For lens, to find the focal length from the radius 1 and radius 2, we have a much longer equation. We call it Lensmaker equation. So look at this one. Don't confuse between equation to determine the focal length of mirror and lens. For mirror, r equal to 2f. Yeah, r is equal to 2 times focal length, or focal length is equal to radius divided by 2. Radius divided by 2. But for lens, because you have two radius 1 and radius 2, so much longer lah equation. Okay. So later we will learn how to use this formula. Okay. This is called Lensmaker equation. With this one. Okay. 1 over focal length. You have to look at the refractive index of the lens material and also refractive index of the medium. That means medium around the lens lah. Okay. So minus 1 over R1 minus 1 over R2. It's not 1 over R2 minus 1 over R1. It's 1 over R1 minus 1 over R2. Okay, radius 1, radius 2. So we have to, this is a longer equation. So, and this is the thin lens. This equation is the same as mirror. Yeah, we use the same equation. These are the positive, negative. Yeah, convention, positive, negative sign. Object distance, if it is a real object, it is considered positive. If a virtual object, it's considered negative. Image also, if real image is considered real. If virtual image is considered, if virtual image, you have negative, yeah, virtual image, negative V. Real image, positive V. Okay, so yeah, this real image is formed at the back side of the lens. Real image. Later I will discuss about this. Yeah, back side and front side. Yeah. Focal length, if convex lens is converging, isn't it? Converging, so positive f. If concave lens is negative f. Convex is converging. Remember I told you about this one? Convex lens, they are all converging lens. Yeah, they focus alike. Concave lens, they're all diverging, f negative. Okay. So concave, f negative. Image distance, if image distance, no, I think, sorry, this one is magnification. This one is wrong already. This one should be magnification. Yeah, wrong. Magnification, if it is positive, is upright. Inverted is if magnification is inverted. I think this image height lah. Yeah, image height. Not image distance. Image distance is one. You see, repeat. This one wrong already. This one is image distance. Image height. So image height, if upright, is positive. If image height is inverted, it's negative. Okay. So let us look at. Okay, this one radius if convex is positive. Radius if concave is negative. Okay, I would. If flat is infinity. Okay, plano, the plane is infinity radius. Okay, let me explain it using this one. Okay, here, this one class. I need you to pay attention to because you learned about mirror before, I don't want you to get confused between mirror and lens. Okay, let us do a summary between these two. All right. Okay, do you understand this diagram, class? Do you understand this diagram? See, mirror, the top one is mirror, below is the lens. Do you see? For mirror, the light is reflected. The light is reflected. Incident ray, look at here. Incident ray, reflected ray. The light cannot pass through. The light is reflected. The light is reflected. But for lens, the light pass through. The light go to the other side. Incident ray, refracted ray. See that? The light, incident ray, refracted ray. The light go to the other side. For lens, the light, incident ray, refracted ray go to the other side. But for mirror, the light is reflected, terpantul. Understand, class? So, that's why, yeah, because this one is the light is reflected. This one, the light is refracted. The light go to the other side. That's why, for mirror, concave mirror is considered converging mirror. Concave mirror is considered converging mirror. So F positive. This one is F positive. This type of mirror can form real image. But for lens, it's not concave lens. It's called convex lens. Convex lens can form real image. Convex lens is converging also. So concave mirror and convex lens, they are both converging mirror or lens. But for diverging mirror or lens, okay, is convex mirror. Convex mirror is diverging. Understand? Diverging, because it diverges the light away. So it cannot form real image. It can only form virtual image. Convex mirror. Same goes to concave lens. Concave lens only diverge the light away. Diverge the light. It diverge. You see this one? Concave lens, it diverge the light. Very much like this. Where is it? See this convex mirror. Convex mirror diverge the light away. Same goes to concave lens, diverge the light away. See that? Convex mirror diverge, concave lens diverge. It's not like concave mirror focus the light, convex lens focus the light. If convex mirror diverge the light, concave lens diverge the light. So that's why this is diverging. This one also diverging. Diverging mirror, diverging lens. Okay? Okay? You can understand this. Just that you need to be more, take some effort to understand lah. Yeah, you cannot understand something without any effort. You yourself must put some effort to try to understand. Yeah, bukan tengok lepas tu tutup tepi sudah. Bukan, tengok dan fahamkan. Itu caranya nak fahamkan. Ya, tengok dan betul-betul untuk fahamkan. Okay. So this is a convex mirror and concave lens. Yeah, all these are diverging. Okay. Just the difference between mirror and lens. Mirror is the light reflected. This one, the light goes through. For lens. Okay, so look again for converging mirror or converging lens. Okay, so because for mirror the light is reflected, terpantul. That's why the real image is formed at the same side as object. The real image is formed in front of the mirror. The real image, you can see the wrist rim is in front. Because the light is at the front. Understand? The light is at the front, so the real image at the front. Yeah, if you put a screen here, it can form a real image on the screen because the light is there. But for the convex lens, the light goes to the other side. It goes to the other side. So that means the light now is at the back side, at the right hand side of the lens. The light is no longer at the front. The light go to the other side. So you can see the real image is formed at the other side, over here. The light is already at the back of the lens. So if you put the screen at the back of the lens, if you put the screen here, you put a screen, white screen, you can see the light form real image on the screen at the back of the lens. Do you see that, class? You see the difference between mirror and lens? Mirror, it form real image in front, but for lens, it form real image behind. Read wrist rim. This one, read wrist rim. And also for virtual image, it's also terbalik. You see that between mirror and lens? For virtual image, because at the back of the mirror, no light, so it form virtual image. No light here, no light. It form virtual image here. Boom, over here, boom. But for lens, the boom is at the front side, because at the front side consider no light because the light already go to the other side. So here at the front there's no light, so here is from zoom here, from zoom at for lens, zoom at the front, for mirror, zoom at the back. Do you see the difference, class? You must know, you must see the difference. And then for diverging mirror or lens, so for diverging mirror, the wood also at the back of the mirror, like this one, zoom at the back, this one, wood at the back. Because at the back of the mirror, no light. No light means virtual image. If no light, it means that if you put the screen here, there's no light to form a real image on the screen. So this image is just a virtual image you can see in the mirror only, inside the mirror only. Yeah, it cannot form on screen. Yeah, this virtual image cannot form on screen. Yeah, remember the difference between real and virtual image? Let's go back a bit. What's the difference between real image and virtual image? Real image can display on screen, like the PowerPoint, PowerPoint you see in your lecture hall, or the real image you see when you watch in a cinema. You watch the movie on the white screen. That's a real image. The light form real image on the screen. Virtual image is an image you just see inside the mirror or inside the lens, but this virtual image cannot display on the screen. Understand, class? Real image form on screen, virtual image cannot form on screen. So like this one lah. See this virtual image, this is called virtual image because you put the screen here, white screen here, there's the light is not there. The light is not there, so it cannot form real image on the screen. So this image is just a virtual image you see inside the mirror only. You still can see the image, but inside the mirror only. You cannot see the image on a screen. Okay, so for lens, the virtual image is formed at the front. See that? Zoom at the front here, wood at the front also. Why zoom? Why the virtual image in front? Because the light already go to the other side. So here at the front, no light. So the light cannot form real image on the screen at the front for lens. So boleh tengok tak mirror dengan lens dia terbalik. Ini macam ini real image in front, this one real image behind. And then virtual image behind, this one virtual image in front. So okay, I hope that you understand this diagram. And then actually what I'm trying to use a different color here. You see, this object one means this image one. This blue object with blue image, green object with green image, red object with red image. Okay, and brown object with brown image. So I'm using different color to identify. Hopefully you're not confused. Okay, about the positive negative sign. Okay, here I want you to pay attention a bit. Yeah, pay attention a bit about this. This is a ray diagram lah, how to draw lah. Okay, how to draw. This one I will go through with you at the tutorial class later. Okay, so yeah, for thin lens also we use the same thing. Yeah, so we also take in the object distance compared with incident ray, image distance and radius compared with refracted ray. Actually, this one in the tutorial class I will teach you more about this. The only thing we still use the same formula, 1 over u plus 1 over v equal to 1 over f, same formula. Only the extra is the Lensmaker equation. Something extra lah, Lensmaker equation. Okay, and yeah, I think that's it. Last, and the magnification also the same formula. See, height of image over height of object, negative v over u. Okay, so okay, maybe let me give, maybe I need to teach a bit, yeah, about this, how to determine, maybe how to, yeah, maybe the Lensmaker equation. I should teach a bit about Lensmaker equation now. Okay, so okay, for thin lens. Okay, okay, before this we learned about mirror already. Mirror, to find the focal length, very simple. It's just radius divided by 2, isn't it, class? Because it only has one radius. It only has center curvature, focal point. Yeah, so it only has one radius, and the focal length is half of it. But for thin lens, it's different. Thin lens, you have two surface. You have two surface. So it has you must consider this one surface 1, surface 2. So this one is considered radius 1. This one is considered radius 2. So for this one, we to find the you know, focal length, we need to use the formula n. This is n of the lens over the n of the surrounding. This is the medium or surrounding, minus 1, and then 1 over r1 minus 1 over r2. Okay, lens means you know, refractive index of the lens. Okay, so depend on if this is a glass, if this this lens is made of glass, so refractive index of the lens is 1.5. Okay, if outside is air, this is considered the refractive index of the medium. Understand? Medium. So medium of air is considered as 1 lah. So later on, this part you just put 1.5 divided by 1, and then minus 1, and then and so on, blah blah blah. Understand, class? So it's just refractive index of lens divided by refractive index of medium. Medium means the surrounding. Then minus 1 over radius 1. So what is radius 1? Put here. What is radius 2? You put here. Then you can find the focal length. This, what formula is it called? This formula is called Lensmaker equation. Lensmaker equation. Maybe when making this lens, we that's why they have to consider the surface, yeah, the surface 1 and surface 2. Find the radius 1 and radius 2. Then only you can calculate the focal length of this, you know, of this lens. Then Lensmaker to make the lens. Okay, but the important thing is be careful with the, you know, the sign convention, positive and negative. So for this, I will talk a little bit about this one for thin lens. The Lensmaker equation. I focus on Lensmaker equation first. So, okay. Class, do you write down notes when I'm teaching here? Do you write down some notes? If not, after this, you watch again this video and take down the important notes. Yeah. Don't just listen and like watching movie like that. Yeah. You must do something. Must write down important notes. Okay, so compare incident ray and reflected ray. Incident ray compare with always with object distance. Yeah, we always compare, and reflected ray we compare with image and also radius. Focal length we don't compare. Focal length we just for lens focal length we don't compare because later you understand. Yeah, focal length we just get from Lensmaker equation to know whether it's positive or negative. Lensmaker equation to know whether it's positive or negative. So if positive means it's converging lens or convex lah. Convex. Yeah, negative means diverging lens. Diverging, so it's concave lens. Okay, so for lens we don't compare with the ray. Yeah, we only compare object distance, image distance, and radius. Focal length we don't compare. We don't compare lah. But for mirror, yes, mirror we compare focal length with reflected ray. But for lens, we don't compare. We just get it from Lensmaker equation. Get positive means converging. Get F negative means diverging. Okay, class, I want to give example. How to use this Lensmaker equation. Especially, I want you to be careful with the radius of curvature compare with reflected ray. Okay, so now let's say I have a biconvex lens. Okay, so to find the focal length of this lens, okay, so we must first draw an object. Okay, draw an object at one side. Okay, actually the object can be either side. You want to put object over here at the left hand side, you want to put object at the right hand side, also can, no problem. Yeah, but make sure when you draw object at the left hand side, you must draw the incident ray from the left hand side, and the light goes through refracted ray at the other side. If you draw your object, class, at the right hand side, then make sure, class, your incident ray come from the right hand side. Understand? Incident ray, refracted ray. Make sure the light come from the object. Okay. If you this one observer is over here. Yeah. Observer. Okay. Make sure the light comes from the object. So if you draw your object at the left hand side, then this surface, the left hand side surface is surface 1 and right hand side surface is surface 2. Okay, if your object is at the right hand side, then this surface is surface 1, the right hand side one, the left hand side is a surface 2. Understand, class? The first surface is always the incident ray. The second surface is the reflected ray. The first surface is the incident ray. The second surface is reflected ray. So you want to draw object at the left hand side or right hand side, no problem, class. I tell you, class. Let's say okay, I give you both situation, and later I want you to find the focal length. I guarantee you, class. both you will get the same value. Both f you will get the same value no matter where you draw your object. You want to draw your object at the left hand side, you want to draw your object at the right hand side, I guarantee you you will get the same value of focal length for both. Yeah, let me tell you, let me just explain you why is it just 49 students over here, class. Why is it just 49 students here? I have over 63 students. 63 students, class. Yeah? This is so irresponsible. Yeah? This is 50, 63. This one including me already. So that means only 48 students. 48 students, 63. No. I have how many students? 23 students per class, so I have 69 student class. 20 students not is 21 students around, not around here. 21 students. Why? You look at the names. Who is not around? Yeah, it's too long list. Yeah, 21 students not around. Why so irresponsible towards own learning, class? Why so irresponsible? What kind of attitude? Yeah. What kind of attitude, class? So don't complain that now 48 students. So don't complain that in the end your result you get such a low grade. Is your attitude that you show to your physics subjects. Yeah. I really disappointed. Yeah, I'm really disappointed with this kind of behavior. Later, yeah, students who don't submit your tutorial, no, don't submit the assignment that I request from you, you are going to get out from the class. Okay, let's get back to here. Don't waste so much time on these irresponsible students. Okay, so look at this one. All right. So you destroy my mood, class. You destroy my mood. What I'm going to try to teach. Yeah. Okay. All right. Let's get back to here. Okay. So I'm putting this one. Okay. Surface one. Okay. This surface. Put it as radius. Let's say biconvex. Let's say this one is 1.2. Okay. And this one R2 is 1.5, let's say, class. Okay, 1.5. Put it as cm lah. Put it as cm, yeah, class. Okay, I assume these two lengths is the same length, yeah. Two lengths is same length. Just the object is at different position. Different position, class. So if these two lengths is the same length, that means if the object at the right hand side, then the radius 2 is still 1.2 cm. Yeah, it's just this one last time is R1, this one become R2 because of what? Because object at the right hand side, so this surface become R2 already, not R1. If object at the left hand side, then this is R1. If object at the right hand side, this is R2. Understand, class? But it's still the same length. And then for R1 here is still 1.5 class. So I just want to show you these two lengths is the same length. Okay, no matter you put the object at the left hand side or right hand side, you still get the same value of f. But you must follow the correct sequence. Okay, now I'm going to use this Lensmaker equation. Okay, which is this formula, class, to show you. Okay, let's calculate together. Okay, that's good. Okay, so I put it, let's say the length, this length is the length is 1.5, yeah, and the air outside is 1. Okay, let's calculate, class. Let's calculate and see. Yeah, I'm teaching so hard here, and those students are not around me. Imagine that, class. Imagine you are me. Yeah, imagine you are me. You are teaching so hard and all those effort goes to waste because you are not around. Sleeping at this time. So irresponsible, class. Whatever I teach is goes to waste. Imagine that, class. What happened? You are the teacher and these students act like this to you. You tell me, what you are teaching now actually is nothing use, is not working at all. You have to reteach those students who are not around. Are you willing to do that, class? So irresponsible. Sudah kena marah masih macam ini. Tidak takut langsung. Okay, so I put it here 1.5 and 1 minus 1. So R1, okay, class. So as I said, you must compare, or especially the radius, compare with reflected ray. So let us first look at the first lens. Yeah, this is the first lens. So first lens, always now I want to substitute the value of R1 and R2, but I cannot just put in positive value. This R1 and R2 can be negative. Can be negative. So I must first compare the radius of each surface with reflected ray. That's why it's very important for us to first draw the incident ray and reflected ray. And then after that, only we can compare the radius with reflected ray. And then only we can know this radius is positive or negative. Understand, class? Now, look at this one. So I want to find R1. Where is R1? R1 is with incident ray. Okay, this surface is R1. Okay, so let's draw the radius. Okay, so this is the radius R1 plus R1. Now this R1 is it same side as reflected ray? Because radius compare with reflected ray. This radius, is it same side as reflected ray? Yes, same side. So same side is positive. This R1 is positive. Understand, class? So I just put in 1 over, because this radius 1 is positive, same side as reflected ray. So radius 1 is, the 1.2 cm is positive. Okay, positive. You understand, here you understand. But those students who are not around, they don't know anything at all. See that? So don't wonder why lecturer becomes so angry. Because everything you do is just going to the drain. Just because the irresponsible people are still sleeping right now. Not in the bed, on the bed. Okay. Radius 2. Look at the radius 2. So look at the radius 2, this radius. Radius. So this is the radius. Yeah, this is the radius. So radius 2. So surface 2 is the radius 2. So so now let's draw the radius. Yeah, a radius. This is radius 2, isn't it? Because the sphere is at the left hand side. So look at this radius 2 and now compare with your reflected ray. Radius 2 compare with reflected ray. Is it at the same side, class? Is it the same side? No. It's considered at the opposite side, isn't it? Radius 2 is at the left hand side. Reflected ray at the right hand side. So opposite. Opposite means negative. Remember, if same side, we consider as positive. If opposite side, we consider as negative. Understand, class? Opposite is considered as, if opposite. Am I recording my sound? Yes, actually I'm recording my sound. Yeah. Okay, so radius 2 opposite to reflected ray. So radius 2 considered to be negative. Because opposite side is negative. Radius 2 is negative. So I must put in negative. Negative what? Negative 1.5. Negative 1.5. Okay. So that is the method to find the focal length for the first lens. Now, let us find the focal length for all the value is already here. Okay, but I'm not going to find out the value of f. I just want you to compare with lens 2. Yeah, compare with lens 2, you can see directly class. Okay, now look at this one, the second lens. So it's still the same thing. Lens over surrounding. Lens over surrounding minus 1. And then 1 over R1. Okay, what is my R1? So if my object at the right hand side, so where is my R1? Look at my R1. My R1 is the right surface, isn't it? The R1 is 1.5 cm. Okay, let's find out the radius one. Is it positive or negative? This surface become the first surface because incident ray is coming from the right hand side. Understand? Okay, so let us so this radius one, what is the surface? This is the radius 1. Then radius 1. This one is the radius 1. So now radius 1 compare with refracted ray. Yeah, radius compare with refracted ray. This radius will compare with refracted ray. Is it same side? Yeah, same side, because refracted ray at the left hand side, radius 1 also at the left hand side. So same side. So it's considered positive. Positive. So put it positive. This should be positive. Positive what? Positive. Radius 1 is 1.5. So positive 1.5 cm class. Positive 1.5 cm. Okay, then minus 1 over. Minus 1 over. Okay, 1 over what? Okay, so this is radius 2. So 1 minus 1 over radius 2. Radius 2 now is radius 2. Radius 2 is this one. Okay, so where is the radius? My radius 2. This is the radius 2. Understand? This is my radius 2. So compare with refracted ray. Is it same side? No, opposite. My radius 2 is at the right hand side, but refracted ray at the left hand side. So this is negative. I compare with refracted ray. I compare with refracted ray. Remember, radius compare with refracted ray, not incident ray. Incident ray only for object. Radius always compare with refracted ray. This one also applies for mirror. Mirror. Radius only compare with refracted ray. So this radius is same side as no. This radius 2 is opposite refracted ray. So opposite, so negative. So we should put negative. So radius 2 is what? Radius 2 is 1.2 cm. So we should put negative. Negative what? Negative 1.2. Negative 1.2 cm. See that? Negative 1.2. Okay. So now, class, you compare and see. Now what do you get, class? What do you get? If this negative multiply negative, what do you get, class? What do you get, class? 1.5 minus 1. Let's work out the first lens focal length. This is 1 over 1.2 cm. Negative means positive. 1 over 1.5 cm. And then for below here, this 1.5 minus 1. And then this 1 over 1.5 cm. And then also negative become positive. 1.2 cm. Do you see, class? This is 1 over 1.2 plus 1 over 1.5. This one is 1 over 1.5 plus 1 over 1.2. Is it the same, class? It's the same. It's the same. It's the same. See? So what I can say is, I teach you already how to find the positive and negative sign for radius and identify which one is surface 1 and which surface 2. Remember, surface 1 always with incident ray, surface 2 always with reflected ray. And to draw the incident ray and reflected ray, you must first draw an object. Draw an object, either you draw at the left hand side or draw at the right hand side. Doesn't matter. Understand? Because it still get the same focal length. You see that? The value is the same, 1.2 plus 1.5. This one is 1.5 plus 1.2. It's the same. So it doesn't matter you draw your object at the left or at the right, but you must draw it correctly. Your incident ray comes from object. And then if object at the right hand side, incident ray comes from the right hand side. And you must identify the surface with incident ray is always first surface. Like this one, the first surface is at the right hand side because the object at the right hand side. This is the first surface at the right hand side. And then you compare carefully, same side positive, opposite side negative, radius with refracted ray. You compare. If you get that all correctly, the answer is correct. The answer is correct. Understand, class? I think that's enough for today lah. So, do you understand today's class? Alright. So I hope that if you tak sempat apa salin nota, nanti tengok balik. Ya, saya pun haraplah yang tak ada dalam Google Meet hari ini ya. Mungkin mereka tahu saya akan upload YouTube tapi tolonglah datang jugalah pagi ini. Jangan hanya bergantung pada YouTube. Kadang-kadang you tak tengok pun, ya. Terlupa tengok atau tak tengok pun, malas. Kalau kita sudah ada amalan yang sikap yang disiplin, pagi datang saja, tak payah tunggu kemudian. Sekarang buat, sekarang selesai. Jangan tunggu masa depan. Masa depan ada benda lain lagi nak buat. Ya? Hari ini punya kerja, hari ini buat. Jangan tunggu esok. Bertimbun nanti. Sengsara. So, sorry lah ya, saya marah ya. Okeylah, itu saja. Thank you, class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Right.
Thank you, sir.